everyone to join the meetup today. My name is Diego Barona. I'm the CTO of Covalent. I'm actually the guy that created the Convector framework, which is mostly what we're going to talk about today. On Covalent, just to talk a little bit about us, what we do is we focus on making blockchain development easy for companies. This involves like creating tools like Convector for developers to create their contracts, but also other tasks like deployment and managing of environments of running networks. So this is our focus as a company. Um, the Convector suite it belongs to the Hyperledger fabric right now. It's co-hosted by the Hyperledger Labs project initiative. So as you can see, you will find the repo of the Convector in the Hyperledger Labs repository. Here you will find Convector. We're actually in the process of graduating the Compactor framework or the Compactor suite as a fully fledged Hyperledger project in the upcoming months, hopefully. But it is completely open source, so and it will be always. So you can contribute to it. You can copy it, modify it as you need for your special project, or you can also contribute or send pull requests to our repository. We will be always open and love to help contributors help us develop in the framework further. Uh, just a little bit about today's the presentation. Just I wanted to tell you that feel free to interrupt me at any time if you have like any questions or I'm not being any clear. You can either like talk in the event in the live streaming, or you can send a message if you're looking at the at the meeting event, right? Uh, you can follow the project, the presentation, either on your computer by cloning the project, or you can follow just the presentation if you're just on a watching basis. But if you want to follow the project in your computer, be sure to clone the repository is located in this um, shortcut URL, bit.ly convector-coffee. And just to make sure if anyone is following in their computer, you will need a couple of things like Docker and Node.js install and things like that. So I actually encourage you to follow the presentation first, and then since there will be a recording, you can follow the presentation on your computer after it. But if you want, you can follow it alongside with me. There's no problem for that. It's just making sure because you will have to download some dependencies and things like that. So I don't know if that will be problematic during the presentation for you. Just to summarize a little bit about what we do, as a company, we transfer companies that are usually to deploy their blockchain solution on a single cloud provider, and then all the participants are in the same cloud provider, and this creates kind of silhouette networks in the space. We kind of transform this shape that is currently right now into a more open space where each organization can have their own infrastructure and where they can deploy their own networks and connect with each other at their will. So we basically decouple the computing infrastructure ledger from the blockchain components and give you the freedom of move to whatever other provider you need or make the necessary changes that you need on your own network. We also help with things like monitoring and giving security to environments, and also provide development and testing and production environments either with Convector or with infrastructure on the cloud. So a typical client that comes to our company is a typical guy that is looking, it has a project and they need to develop this kind of Hyperledger project. So we provide help on all the steps where they can see or ask for help in the whole process. Like we help them figure out the architectural solution for their own problem. We give some advice. We collaborate with them, even doing some code in Convector if they're actually need help in that section to develop the smart contracts on their solution. Convector already automates the testing, so you will have unit tests and end-to-end tests to integrate and improve your solution. We also have support for the automation of the deployments through the continuous integration and continuous delivery. Um, as said before, we also have some monitoring so they can monitor their environments for the production grade deployments and to build the interfaces through our engine, since the tools that we have are API driven, so they can control everything since a single API programmatically. They can create networks, they can create channels, they can add users to their own networks and things like that. Everything through an API. Uh, just the ecosystem, how it looks like, is mostly like this. For the development section, we have Convector, right? It's now being used by more than 50,000 downloads on NPM. Most of those developers are looking for Convector to migrate from Composer. You know, Composer has been recently deprecated. And well, it's been a year since they first announced that, but officially it's just been a week. So there, we have a lot of developers in the community looking for to migrate from Composer, and they're finding value in Convector. That's mostly what we're going to talk about today, how to build the contracts and stuff like that. Convector, it includes some mock testing, so you can mock your solution locally without having to worry about all the blockchain complexities. It is written in a way that you can have type checking. So even if you're starting to develop your code, you will have like warnings about if you're confusing any type data on the storage that you want to commit to your blockchain. And it also generates REST API for all the contracts that you develop on it. Um, Convector developed or is created in JavaScript using TypeScript, which is a Microsoft superset of JavaScript. It will compile down to JavaScript at the end, and this is going to be installed as a JavaScript chain code in any Hyperledger Fabric network. So you can take this chain code and install it on your own Fabric or on any other blockchain as a service environment, as well as in Forma, which is one of our tools. Um, for debugging purposes, we have for Hurley. Hurley creates local Hyperledger Fabric networks for you. This is meant for development, so it will create, using Docker, a local network using Fabric 1.1.4. Just in a couple of minutes for you, so you don't have to even worry about how can I create a network to actually test my contract. Hurley will help you to set up a project, and you specify, hey, I need X amount of channels and X amount of organizations and X amount of users, and it will create a network for you. It also provides live debugging. This means is that you can put a breakpoint in your chain code, and it will stop the execution when the transactions gets to that section in the blockchain, in the chain code, sorry. So you can just inspect, since this is just JavaScript, you can inspect, do some changes on the code, do some console logs and things like that to figure out what are the problems that your smart contract is having if you find a problem like that. It also has this hot reload. So if you make any changes to the chain code while you are developing, it will automatically reload the chain code and compile it for you. So you can just continue like making changes, debugging, finding some problems, and repeating the process again and again. It also has private data support, so you can test your private data collections if you're familiar with Fabric already. Private data is just to support that in a single channel, just certain organizations will be able to read certain data. Um, so you can test all this with Hurley as well. And when you're done with Convector in Hurley and you have already developed a approved solution and you want to go to production or you want to go to a real environment to live testing, you can go and deploy with Forma. Forma is our last stage on the ecosystem when you can go and deploy your Hyperledger Fabric in multi-cloud environments. So you can go and deploy it on your own AWS or Google Cloud or whatever cloud provider you are actually using. It deploys using Kubernetes. Sorry, and you can use it to deploy a single development or testing network, which is this scenario, or you can use it to connect with multiple other organizations that they will have their own infrastructure on their own cloud provider. And Forma will be make all the connections for all the environments, so you can test it out together, or go to productions in the same network, right? A little bit about the scope that we support. Convector right now supports Hyperledger Fabric. Convector itself is agnostic of the blockchain technology. It is made so that you can create adapters uh, to communicate with the actual persistence layer. Right now, we have created an adapter for Hyperledger Fabric, but we are in the process of exploring some other adapters for our technologies. For example, Corda or Quorum. Uh, we we're in the process. Yeah, again, we're in the process to make like the discovery path on how we're going to support all the other blockchain technologies. It's a big challenge since Convector is made in JavaScript and Core, for example, is made in Java. But TypeScript makes some kind of utility on that you can convert TypeScript into WebAssembly, for example, and Ethereum supports WebAssembly as well. So there can be some kind of bridges in there that we can develop. So, but right now, Convector supports Hyperledger Fabric. Forma, on the other hand, it does already supports Hyperledger Fabric and Corda, so you can create networks on both of them already. And we are in the process on supporting this technologies. And to be able to deploy all the solutions, you can use basically any cloud provider out there using Kubernetes, even your own bare metal or in-premise Kubernetes. So, okay. Now, starting to get into the topic today, I will be presenting to you guys a coffee traceability project. Uh, so essentially, this project is about that we have some participants and they're coffee producers. They have a plantation somewhere and they grow coffee on their plantation, right? Uh, and they will export some batches of this coffee. They will sell these batches of coffee into another roaster, coffee producer. They will combine all this coffee, all these boxes of coffee grains into a single silo. And after they pass through a process of roasting the coffee, it will have a finished product, which is going to be a coffee bag or a coffee, yeah. So at the end, you will have this finished product, and our goal for the example is that you will be able to tell or to take a cup of coffee and tell, okay, this coffee is produced by X amount of Bob's production and X amount of Alice's production and all the participants involved in the process. And this is essentially the goal of this. So I'm actually going to switch to the code right now. And I want you to confirm me if this is, if this looks good on size for your end, or if I need to make it bigger. Does it look good? Yeah, I guess so. All right, I'll continue with this then. So Convector has a couple of utilities. One of the utilities that we have is a Convector CLI project that you can start. You can install that by running npm I -g, sorry, or Civu Convector CLI. If you run this command on your computer and you have npm installed on your computer, you will end up having a command globally named conf. And this conf, if you execute it, actually, let's do some tests. I'm on the coffee. Let me, okay. I will run conf new my project. Right? If I run a project like this command, you will see it will create me a folder named my project, and it will scaffold all these files for me, which at the end is going to look like the files and folders that I have in this project already, which is the one that is in the repository I showed you before. This is going to create me what is called a monorepo. A monorepo is a repository package or folder containing multiple different packages inside. We do this by using Lerna. Lerna is an open source JavaScript tool to handle monorepos. But as you can see, it will be basically composed by a root package JSON file here in the root. And you will also have this packages folder where you will have all the different chain codes components that you create for this project. Right now, the only chain code that I have, well, the two chain codes that I have is the coffee chain code and the participant chain code. Those are going to be the chain codes that we are going to be focusing today. But let's explore a little bit about the overall project. So at the root, you will have this package JSON in here, and it will come with a set of scripts are ready for you to execute them. So if you run the command npm run and restart, this is all included in our README. So if you go to the README, you will find the steps to install a project. So you first run npm I to install the dependencies, and then you can run npm run and restart. And as you can see here, the env restart, what it's going to do is invoke Hurley. Hurley is the other tool that I was talking about with you, that is going to be creating a local Docker network and install a Fabric network on it. So in this case, I'm calling just new, and I'm passing that I want to create three users for this new network that I'm creating on Hyperledger Fabric. I have already run this command because it's going to take like a couple of minutes, 3 minutes or something like that. But at the end of that, you will end up with something like this. Let me make this bigger. So you will have, if you run Docker PS to see all the process that you have running in Docker, you will end up with, let's see where are the names. That's it, yeah. You will have a peer for organization 2, a peer for organization 1. By default, it will create 2 organizations if you don't specify otherwise. A coach to be for peer 0 of organization 1, a coach to be for same peer organizations 2, 2 certificate authorities, 1 for each organization, and 1 auditor for this network. it will be running on a solo ordering mode on Fabric. If you're not really familiar with Fabric itself, don't worry about this. It is just creating all the components that you need to run and test your contracts properly. Uh, but this is just to make sure that you have a network running. So if you're following the tutorial, make sure to run and restart as soon as possible because it will take a little bit of time. Uh, and the other thing that you will most probably want to run right now, before we go deeper into the examples, is npm run cc start and dash coffee. What this is gonna do is we have a script in here, cc run start, cc npm run cc start. What it's going to do is install the smart contract that we have in here, the coffee contract. And you can see actually the definition in here. We have a coffee.config.json, and this is the file that Convector uses to combine multiple controller or chain code projects into a single chain code, Hyperledger Fabric chain code. So if you use this file, you specify all the controllers that you use in this section. We're going to take a look a little bit about the controllers in a minute, but essentially we'll combine all these packages into a single compiled JavaScript project. It will put it in here, and it will go and send the command to the Hurley network to install this smart contract on it. So yeah, those are the two packages that if you're following the tutorial with me, be sure to run right now so you can just start easily later. So let's explore a little bit about the chain code projects. So let's start by participant. In this case, let's go back a little bit. Example. In this case, I model this problem into two different sections. I modeled the participants registration, which is going to hold up the names and the information of the different participants and stuff. And I modeled separately the coffee transactions or the coffee models going on in this problem. Just to have things separately, you can, in Convector, there is no rule that make you tell or design the problems like this. You can define everything into a single controller if you want. But you know, in software development, this is not a good practice to have everything in a single package. You start to splitting up the problem separately, and this is better for administration purposes. So here I have a participant controller, and let's explore how a model looks like. Convector is based on a controller model pattern that is really familiar for software developers already. And essentially it makes use of TypeScript, as I mentioned before. So you might see some weird things like this kind of syntax like this. This is TypeScript information. So it is just passing typing information to the compiler. So it can warn you on real time if you're making a mistake or about the properties that you have. But this is plain JavaScript at the end under the hood. Just if you're removing the types, it's just plain JavaScript. When you want to create a model in Convector, you just need to extend the Convector model and pass which class is going to be end up this model looking like. And then you just define some public properties that this model is going to have. A model at the end is the shape that we want to store in the ledger. This is what Convector is going to end up saving on the ledger. And if you go to the CoachDB instance, for example, and you look to the records, you will find the exact same result that you are looking in here. We don't do any much transformation, and that's why we use the models, so you can just define and shape the data that you need to store. A model only needs a requirement is that it needs a type, so we can distinguish the different amount of types, because on Hyperledger Fabric, it will all be casted and converted into a single string. So we need to keep track of what type was this in the Convector model. So that's our only requirement. All the other properties that you can define are up to you and up to your problem. In this case, I'm defining just name and identity. And you will see that I'm using this kind of decorators. Those are part of the ECMAScript 7 specification in JavaScript, and they are also available on TypeScript for you to use. What it does is just putting some meta information on these properties, meta information that Convector is using to make some validations, for example. So it will make sure that whenever you are referring to some sort of data as a participant model, it will apply all these validations and all of these castings. So it will make sure that the data that is coming, it is what you were expecting it to be, right? There are some other decorators, like for example, read only, that this will make sure that if a value was assigned on the ledger, it won't let you assign it again, or are required that will prevent you to save this model on the ledger if field like this is missing, right? We also have a for decorator, which is the default, which I'm not using here, but you can pretty much use it like this. I know you will probably know what the default does, right? But yeah, I will essentially apply the default before saving the data into the ledger. So you can have the field blank on all the process of your stack, and just before saving it to the ledger, it will apply the defaults. This is very convenient. So yeah, other than the properties, you can have some additional methods in the model. Like in this case, I have this get from fingerprint, which is just an utility that I will be using a lot in the coffee controller, which is essentially I'm going to pass a fingerprint of the certificate of the user, and I will be making a query to the CouchDB from the ledger. So this query is telling, okay, use the participant model. All the models have this method, which is query, and you can pass a Mango query to it. In this case, I'm specifying the selector is going to be this same type that I'm specifying here. And the identity, which is the property that I was declaring in here, it has to match with the fingerprint that I'm passing. So in this case, the kind of authentication method that I'm using for this scenario is I will be registering new users in the chain code. And when I register these users, I will be copying their certificate fingerprint and store that in this property. So I can use this later on subsequent invokes to my chain code to verify if this is the right owner or not. And you will see how this works in a little bit. Okay, no questions so far?
Nope, no questions.
Okay, cool. Let's see, high floating, yeah. Okay, so on the participant controller is essentially the same thing. You have a class and you extend this from a Convector controller. You will have some sort of decorators here as well. So this decorators is telling Convector how is this controller going to be registered on the chain code. So on a single chain code, you can have n amount of controllers in the same chain code. So this is just like a namespace for it to identify which is one. And then you will have methods on each controller, right? In this case, I have an invocable. This is to tell Convector that I want this method to be exposed and be invocable in the chain code. I can have other methods that are not precisely going to be exposed through the chain code API that I don't want that other people call directly, but are like utilities for the existing methods. But in this case, I do want this to be invocable. As I tell this method is going to be named register, and I pass some parameters to it. I define some parameters. In this case, I just have one parameter. This parameter, I'm telling it with using TypeScript that I want this to be of type participant participant is the model that I defined previously. You can see I can command click and it will take me to the participant model. And I am telling with this param decorator to Convector that whenever someone calls this function, I want it to validate that whatever comes in here looks like a participant object. So it will reject if it doesn't look like it. So this way I'm protecting myself that whenever I get to the body of this function, I already have validated all the parameters that I get passing this function. On Hyperledger Fabric, when you define the chain code and when you invoke the chain code, all the arguments that you pass to the function, they get passed as an array of strings. So if you intended to pass an object, you have to parse that object from the strings and then figure out like what is the shape of this object. We do all that task, all those tasks for you using the param decorator in here. So in the chain code, in the function body, what's left to do is pretty minimal. If it gets to this point, it has already validated the arguments length of this function and that the arguments have the shape that I want. So everything that is left for me is to focus on my business logic. So I don't want participants to get registered twice. So what I'm going to do is in here, using the participant get one method, this is going to query the ledger and I'm just passing an ID to it. And if it finds something, it means that another participant was already registered with that ID, right? So just by throwing an error, I'm rejecting this transaction. And if all the peers reject this transaction, so nothing is going to be committed, right? So yeah, I'm just rejecting the transaction, saying the participant with this ID has been already registered, and I use a message. This error message that I'm throwing, it will be available to me on the client that is invoking. So it's really good to have like a very good message in here, or even tokens like participant already registered or something like that, right? So you can just use some sort of validation on your client.
Got a question?
Yeah.
When did you authenticate the participant? Where is the identity?
Yeah. Let me get to it. All right, I will answer that question in like 2 minutes when I get to the other chain code, just so you can see the full flow of this authentication process. So in this case, I'm just setting participant identity. I'm here in this is the beginning of the process actually, because on participant identity, I'm overriding, okay, so whatever object or property that was passed to me in this participant object, I'm going to override if it already has something defined, or I'm defining the identity property with the values of this sender. This sender is special in Convector. If you extend from the Convector controller, you will have this sender available to you. And what it does is it contains the fingerprint of the certificate of the user invoking this function. So with this, you can make sure, and on subsequent invokes on other functions, you can use the same this sender to verify if whoever is calling or is invoking this function is the same guy that was registered on the first place and stored the value in this identity. And since no one can mock the certificate, only the one that has the private key, you can trust that if the certificate fingerprints matches, they will be the same participant. And this is how you authenticate the users in this section. After all this, you just have to run participant save to save this data on the ledger. So this is not actually saving, it is just telling the transaction, hey, these are the values that I want to write to the ledger. And if all the peers agree on the same, they'll send the transactions to the orderer, and the orderer will save that data on the ledger. But on practical terms, when you write this sentence here, you're saving the data to the ledger. The other methods of this controller are pretty basic, just a get, where you get an ID, which is a string, same thing. And then you do the same, participant get one. If this exists, if this participant does not exist, you can just return an error. It says that it doesn't exist. Otherwise, you can just convert the model to a JSON object and return it back to whoever called. And for the get all, to get all the participants, you can have this method that is participant get all. It will get to the ledger and find all the participants that have the same type. That's why the type is important in here. It will look all the participants or all the records matching that type and compare and get back to you. So you just need to convert that to a JSON and send it back to whoever called. Just before I switch to the coffee, so we can finish looking at the authentication mechanism, I want you to take a look about a unit test so you can have a better idea on how a Convector controller is being called from the outside of the control, you can this adapter. I told you the way that Convector is communicating with a storage layer is through adapters, and that's why it's so easily for us to use a mark adapter or a fabric adapter or any other kind of adapter. We actually have a couple of other ones. I will be explain those at the end. But in here we're using the mark control adapter. This is going to emulate a ledger with all the querying properties, with all the saving properties and all stuff, but in memory in this unit test. So I'm initializing the adapter in here. And here I'm just creating a client. A client is just like, it has the exact same shape of the participant controller. So we can reuse actually this piece of code that we have already created, this controller. And I injected an adapter to it so it can know all the instructions how to manage and how to communicate with that. What I will end up is going to be a Convector controller client, which has this exact same fingerprint of the controller with some extra methods. I will initialize this adapter with this mark controller adapter, and I'm telling it, okay, I'm going to use this controller. Sorry, I'm going to be using this controller. This controller is located in this path. So make sure to read that and use it for when I invoke some methods on it. All right. The adapter also has some mock users that you can create on the fly. So you can test the values of this sender properly, that they are going to have the different values that you will expect. So you can test all this authentication mechanism flows to make sure they work correctly. In this case, I'm telling the adapter to create a username test. I am creating a new model in this section. Just create a new participant model, and notice how I'm reusing the exact same controller and model that I created before. Those controllers and models are going to be compiled and saved in the chain code, but I can also use those as the client components in my backend application. And I actually can use those same controllers and models in my front-end application as well to communicate over the whole stack. Here I'm creating a new model. I am passing an ID. All the models need an ID as well. And I'm passing the name. Notice I'm not defining the type because the type was already defined in the model. And I'm not defining the identity because it's going to be overridden anyways in the controller. And at the end, I'm going to be invoking using the participant controller. Remember, this is a client, Convector controller client. I am using this special function of the controller client, which is going to tell which user to use to run this invoke. So in this case, I'm using with user test, which if you remember, I registered previously in here. And I'm calling the register function. If you remember well, this is the register function that I had in here, right? It requires a participant model to be passed, and that's exactly the thing that I'm passing here. And just, okay, so this await in JavaScript, if you're not really familiar with JavaScript, this await is because this is going to be an asynchronous function. This is going to send on a real ledger, is going to send the request to all the peers, way back for the peers responses, send out responses if they match to the orderer, and wait for the order to confirm that the block has been already added to the ledger. Convector is going to wait for all of that. And if you just need to put a wait, and you're safe to go that when it reaches this line, the data was already saved on the ledger, and you can be sure and make calculations predicting that the ledger is going to be updated by this point. All right, so in this section, I'm just using the adapter. Remember, the adapter is a mock adapter to make use of one of their internal methods, which is get by ID, and I'm passing an ID just to make sure that the whole process save the data that I wanted to save in the ledger itself. So it's going to get back to me with a model, and I can just make some assertions that the model exists and that it has the same type that I want. In this case, I'm going to check that the identity that was saved is the same identity that my adapter returns for the user that I previously registered here. So this get user fingerprint is going to return me the fingerprint of the certificate created for this user, and I'm comparing that with the identity saved in the chain code, and they need to match. So yeah, I think this is mostly for the participant model. Let's switch to the coffee, which is a little bit more complex logic. I don't know if anyone has like any other questions besides the authentication that I see have pending to respond. Okay, so let's start first by exploring the models that I have in here. In this case, I have 3 models. I have a grain batch, which is going to be the batches exported by the producers in this section. I have toast batch, which I actually named this wrongly. It actually is roasted, not toast. And I have a grain batch portion. The grain batch portion is because this roast coffee producer is not actually going to use the whole batch of coffee into a single silo. It can use just a portion, let's say 5 kilograms of this batch into a single mix. And they actually tend to do that to mix different kind of coffee grains and coffee qualities, and they don't really use the whole batch. They use just some portions of it. So I'm going to create a grain batch portion model, which is going to looks like well, it has a type, and it has a grain batch ID, which is the original batch. It has a toast batch ID, which is roast again, sorry, which is a reference to this model. And it has a weight of the amount of product of this grain batch. So if you start to look on this, and you will see we start to working with references, you can see this tends to looks like a NoSQL database, right? When you start designing documents on a NoSQL database, you start referencing documents by the RD on some other sections of the application and stuff like that. So we can do that in here at the end. Convector at the end, Hyperledger Fabric is just a basic JSON structure of a key and value, so we can reference some other IDs inside their values, right? Let's see the coffee batch a little bit, just quickly. I think time is flying. All right, so for the coffee grain batch, we have a location, just a string of where this coffee producer is located, the height about the ground, the quality of this coffee, and for the quality, you can see this is actually an enum that I have defined about this class, it has two keys. I can tell with this job, which I haven't mentioned at all. Job is a library that we use for the validate decorator. It is a really useful library to make some sort of validations. So far, you have seen that I only use job string, for example, but you can use job number or any other data type, and you can add some modifiers to it. For example, use a minimum of a 0, or if it's a string, choose validate that is one of, and I'm passing this expression. This expression is converting this enum to an array of values. So at the end, Convector will validate with the help of job that whatever is assigned to this property is just one of those values, right? Here I have the weight of this batch and the price of this batch, the producers, and it's going to be an array of strings. Those strings are identifiers to the participant models previously registered. I'm going to store the created date and the current owner of this grain batch, because at the beginning it might be the producer itself, but when it sells it to the roasted coffee producer, now this is going to be the owner of that batch. And we are always going to be keeping the reference through the certificate in here. Looking through the coffee example, the controller, this is, let me see, okay. So in here, I'm going to create a coffee grain batch. Again, I received the batch as a model here in the parameters. I make the same validation as that I did on the participant. I'm making sure that it exists or not. If it exists already, I'm returning an error. Otherwise, I'm going to be using this utility function that I mentioned before, participant get from fingerprint, just to get the participant model back using the fingerprint of the sender. Remember, the sender is who is invoking this function. So I'm going to graph that with the variable creator, and I'm going to assign the batch owner is going to be whoever is calling this function, right? And then I'm going to be doing a batch save. And now to answer the question, how the validation works, how this mechanism works is, for example, on the sell grain batch, which I'm going to sell a grain batch produced before, I'm passing the batch ID and two is going to be the fingerprint of, no, sorry, 2 is going to be the ID of another participant, right? I'm going to do the same thing, make sure that the batch exists already, and then I'm going to look up for this sender in the participant model. If this returns something, and I will compare this with the batch owner. If the batch owner does not match the sender ID, is because, let me actually see, sender ID batch owner. Yeah, if this does not match, it means that this batch was property of another different user. And this is all because I first checked the participant model using this sender, and this sender was the fingerprint of the user invoking this function. So I can trust that whoever is calling this cell grind batch function is going to have the ability to control this batch ID, because I previously fetched the batch ID and the batch owner matches the sender of whoever is calling the function. I don't know if this answered the question that you were asking before.
Yes.
Yeah. Okay, cool. If it doesn't match, I'm going to throw an error telling so that this participant is not able to solve this batch. I'm going to change the owner of the batch, make it very, very important. If not, I'm not selling it at all. And then I'm going to save it on the ledger. So yeah, the whole process looks like this, almost for all the functions. The get green batch is just retrieving one batch previously registered. And I have another method that is the created toast batch, which is the roast batch. Actually, it's not toast. Following the same principles, but this one is kind of special because it will have an array of coffee grain coffee grain portion batch. If you remember the portion, it was just a portion of the whole batch. And I'm going to name this composition. So this is, since I'm going to create a new roast batch, this is going to tell me what is going to be the composition of this roast batch. And this is what is giving me the whole traceability uh, structure here. So I'm going to get a coffee grain batch, and from that grain batch, I'm going to also get, let me see, coffee grain portion batch get, yeah. I'm going to get all the portions already consumed of this batch, so I can make sure if, for example, another roasted batch was already consumed, like, I don't know, 50 kilograms of the 10 kilograms, I'm going to make sure to don't double spend those amounts of kilograms. So I have this utility function in here that is just making a query to select all the portions that has this grain batch ID and count, so I don't do like double spending error in this case. Uh, and actually in here I'm just making the validations that it doesn't exceed the limits. At the end of it, I'm creating a new coffee grain batch and save it to the ledger. Uh, uh, let me see. At the end, I'm going to define the width, the calculated width of all the portions summed up, the producer and the current owner, and save this to the ledger. So at the end, I have a get those batch that is going to be mostly the same, but it's going to calculate the composition based on this function here. It's not that funny to see, but let's make sure that you can see all this in action. For the unit test, I'm actually going to run that right now. npm run test. If I run, oh, let me see. Oh, I switch coffee, right? npm run test. At the end, you will see the test for this coffee. This is the one. It's going to do the same thing that we were doing before. It's going to create a mock controller. It is going to initialize the adapter using both of those controllers because I'm using both of them. I'm creating some fake users as well as in the other unit test and registering those users with a different name, producer A, producer B, and toaster. Uh, I am calling this that it should be able to create a grains batch, and you see I'm just passing the properties that I care about in here. For the producers, for example, I'm just passing the IDs of those producers that generated this batch, and I'm just making sure that it exists. And it also should create a roast batch. So you can see here, I'm creating all the batches again, creating the batches in the controllers, and then creating the roast batch, uh, and I'm making a call to the create toast batch, passing the batch that I just created, which is this, and passing the array of composition for the grain batches, right? So I will have the grain batch 1 in here, batch 2, and batch 3, and the portion that I'm going to consume from each of those in here. And at the end, I'm going to be querying the ledger. You can see that here, coffee query, get toast batch with the batch ID. And this batch is going to have all the composition and all the traceability information about this batch. And I'm going to pretty print it with this. You can see that in here, actually in the whole unit test flow, you will be able how it's, for example, making the invocations in the ledger in the mock adapter. You will see, and transaction ID, arguments, yeah, init controllers. Okay, this is not. Let me see, participant register. You can see here, it's calling participant. Remember, participant was the controller, register was the function, and it is passing this parameter, and here it's calling again for the parameter for participant B and for the roster. And let me see. In here, I'm creating the grain batch and all the stuff. You can follow all the transactions going on in here. These are all the logs that it's going to give on the chain code as well if you're running on a real Hyperledger Fabric network. And at the end, it's going to have the pretty console log that I said. So the batch and the ID of that batch is composed of 30% from batch X, which is located on San Jose, 100 meters above the sea level, and the participants involved are producer A and producer B. This another batch. This another batch is just 53% with the rest of the information. Same thing with this. So the important with this is that you can see how you can split and join models using Convector to have your own traceability. One extra thing that I want to show you is you can, I told you that on the whole stack is you have Convector to test things locally using unit testing, for example, with the mock adapter, but you can also test this on a real Hyperledger Fabric network, and that's with the help of Hurley. If you remember at the beginning, I told you to run the npm run and restart command. That is to generate the Hurley network. And this end-to-end test is running the same cases that I'm running the spec, but with the help of Hurley. The unit test, the spec file using the mock controller adapter is really useful for running the transactions really quick because it's going to be all in memory. But the end-to-end tests they're going to be asynchronous and take a little bit more time because they need to send the transactions and get to consensus and things like that. But you can still have this end-to-end test to make sure that all your code that you are doing on your controllers and models is going to actually function or work as expected in a real Hyperledger Fabric network. So in this case, we are using the Fabric controller adapter instead of the mock controller adapter we used before. We're passing some configurations to it. You can see here, I'm saying, okay, use the channel CH1, which is the default channel that Hurley is going to create. Use the user one, which is the default user. Use the chain code coffee that I previously installed before. And I'm passing all the cryptographical paths that Hurley creates for me already. So I'm just passing this. When you create a new project with Convector CLI, it's already going to create you the end-to-end test file with everything already initialized for you, so you can just get into testing. It also will make the connections with the CouchDB. So with this CouchDB storage, I'm going to tell you, okay, open localhost on port 5084 and look to this database. Actually, let me show you that in fact it works. I can go here into the utils and I will see ch1 coffee is already registering here. I already run the end-to-end test file, end-to-end tests are ready. So I'm going to have some IDs already registering here. So you can see it's going to have all the information that we were talking about in the models. But let's run it again, just for fun. npm run test E2E is going to execute all the transactions in the Fabric network. This is really useful, and this is where if you want or if you're having any books, you can. There's actually another command which is let me see. Instead of running npm run cc start, you can run cc start the book. Oh, looks like something is broken. You can start running cc start the book, and this is going to start up the chain codes in the book mode. So you can put some breakpoints on it and have the live code debugging that I was going to tell you. But in this case, I started with just cc start, which is going to be the classical way of Fabric to install the contracts. Let me see what failed. I should create a tools, but I must have changed something because I just run this before the test. Let me see. must be colliding. Did I fix something? Let me see. No, it's going to create a unit test as well. Let me run it actually again. Test end-to-end file. All right. So yeah, if you want to like put any breakpoint or do a like a live debugging or something like that, you can start the contracts using the SSE start debug. Another thing, while this is running, that I want to show you is Convector generates REST API. I showed you that before, right? So if you go and install npm run I, sorry, npm I /g or cvu conf REST API. This is all in the presentation that we're going to show you, so don't worry about this. If you install this, you will have the REST API generator for you. If you run conf REST API generate API and you say, okay, I want to generate an API for coffee, and I think I have to pass the coffee config.json, which is this file telling it where to look up for all the controllers and stuff like that. It's going to create for you this server folder in here. So you can, well, this is a generated code, but you can hook on it and start doing changes if you need to, or you can just leave it unchanged and generate it every time. Essentially, what it's going to do is, again, it's going to create a fabric controller adapter, the same thing as with the end-to-end tests. It's going to initialize that based on some default values, but you can override those default values to communicate with another fabric network using a .m file, like I'm putting here. And it will generate some routes. Actually, let me show you, because it's going to read this file. It's going to read this JSON file where I'm telling it what functions do I want to expose from my controller. So I'm telling, okay, from the controller participant controller, expose the function register with the verb post, and export the function get with the verb get, and things like that. So I can go through all the functions that I want to expose through this REST API. It will read that file and it will generate at the end these routes that you see here. This is using Express for you, so you familiar with Node.js. This is going to use Express to generate all the routes with different parameters, and it will generate a controller, which is essentially doing the same thing that we were doing in the unit test, which is calling the participant controller backend that register, which was the function, and passing whatever comes in the body, right? In the participant property inside the body. So this will generate you an API, and it's going to look like npm run npx run server scope server. Oh, sorry. Start scope server stream. See. Oops, no, I am not running it correct. Oh, I missed something. There now. All right, this is going to start the server. Yeah, it's running on port 8080. So we can do things like going to Postman, for example, and trying to register a new participant to the network. So I'm calling to HTTP localhost 8080 on the participant register route, sending a post. I'm going to send a participant, and I want to register a participant 413 with the name Diego. Let's see, send the transaction. Okay, I got a 200. Okay, so if I go and do a participant get, which says the ID that I put, I will be sending this transaction. And suspected is going to return me the ID, the register, the type, and the name, and the identity assigned to this participant. This, remember, is the same fingerprint. The fingerprint assigned to the user that I'm using for this REST API. And I can go to the coach TV and actually look for an ID looking like this. It's actually here, 4123, yeah, this one. So it's the same value that we have in the coach TV. And same thing as we do this, we can call, for example, the create grain batch, for example, and say, okay, I'm going to be using this producer. The batch is going to be number 9876. Um, yeah, all the information. Yeah, let's leave it like that. So I can create the coffee grains batch. I get a 200K, and I can come and query for these same batches. I can get all grain batches as well. And let's see. Okay, this is the batch that I just recently registered, right? With the same producer. So you can do all this stuff like this. I am running this with Hurley. Um, Now, to finish, I think the presentation, there's a couple of more things I've got to talk. First is just to show you. Okay, so now you have, yeah. So now you have your controllers and models working. You have your unit tests working. You have test everything locally. But now you need to deploy this to a real cloud and like test it out on a real environment and share the URL to someone else so they can give it a look. And for this, you can use Forma. Forma, as I told you at the beginning, is to automate your infrastructure deployment of Hyperledger Fabric. So in this case, if you want to just create a new Hyperledger Fabric network, you just start by clicking new network and fill in a couple of parameters. So for example, I want to create a new network called Austin Coffee. Yeah, and you can pick up if you wanted to create just a quick network. You can do it fully managed by WorkZero by us, or you can create a multi-network network. I mean, Hyperledger network on your own infrastructure if you want to. Just need a Kubernetes cluster to do so, and then you pick up all the organizations that you want to be part of this network. In this case, I will just pick up this organization that I have created previously, which is Diego, and I click create. This is going to send a proposal to this organization telling, hey, the organization Covalent, which is the organization that I'm using right now, wants to create a network with you. Do you agree or not? And then we can deploy that one. I have already created one in here. So this coffee traceability, you can come here and see all the components that you are running in your cloud. So you can see, for example, I have an order in here. I have a beer with all the details, the username, the password for the beer. I have access to the Coach TV, and this is in a real cloud infrastructure. So you can notice this URL, copy it and send to someone else, or put it in a real life project if you need to. And it also allows you to create the users. So in this case, I have created Josh, Alice, and Buff, which they were all participants and you can create just a new user just by providing some username and password. Really easy. The other thing you can do in here is actually having your metrics of what's going on the blockchain. Because I want to show you this real quick. This is going to give you just some performance stuff about the components running on the blockchain, but it can show you also some fabric statistics. So, for example, if you start sending transactions, you will see the transactions diagram here start increasing and all things like that, like transactions per minute and all stuff. And the good thing is that this is all API driven. So if you want to create some continuous delivery integrations for your smart contract to, for example, deploying or just testing, create a new ephemeral network, test it and shut it down, you can do so. You can also create multiple ledgers in here, multiple channels. And on each channel, you can just install your smart contract. I actually went to this process, to the project that I have, and I copied this generated folder. I just zipped this folder into a single zip file, and I go here and fill up the name that I want for my chain code. I uploaded the smart contract. Pickup is an Node.js smart contract, so any compactor contract is a JavaScript, is an Node.js contract. Pick up the version. You can pick up if you have any private data or need any first invocation, and then you will have the smart contract running here. You can operate it and do all kinds of stuff, right? So yeah, with that, you can integrate easily when you have your project running to run, for example, spin up this server API, just Dockerize this, put it in a Docker container, put it in a server somewhere, and then you are ready to go with your blockchain project. Yeah, I don't know if anyone is having like any questions about the whole presentation.
About what? About
the presentation overall, like any questions that you may have at this point.
Yeah, I have one question on when you were doing the roasting, I saw that you had a condition where the consumed is some number. But let's say if the user is hitting the button and saying, so one of your users had 15 kilograms of coffee, and then you, what if they double click it, you know, there's delay. Did you have partial transactions in there? I don't know if you, does it cover like where, you know, if the network is faulty and the guy is double, like entering multiple times beyond his amount that he has, do you have partial?
Yeah, actually, Fabric is actually going to take part on that, because you cannot send on Fabric transactions that read or write the same key twice. So if you, for example, try to send this transaction twice and like at the same time, and try to double spending because it's a concurrent transaction, things like that, Fabric will actually reject both of those transactions with an error which is named actually is MBCC. I think it's read conflict, if I'm not mistaken.
Also, how does it know to invalidate the valid? So one of the guys had 15, and let's say I do 15 once, and then I do 15 again to roast it. The first one should have gone through, but you're telling me the valid one will not go, and the invalid one will not go.
If there's been sent at the same time, Fabric will reject the transaction. If that's what you mean, I almost can hear, but I think that's what I understand from your question. Is that at the same time?
Yeah. So the guys, yeah. So you're telling me one of the users had 15 kilograms, and you're saying that if I say roast 15 kilograms and then I hit again because I'm impatient, 15 kilograms again, the valid one and the invalid one will not pass. Is that what you were saying? If I understand?
Yeah, correct. If they happen at the same time, Fabric will reject both of those transactions because they are reading and writing the same key on the same transaction, on the same block. If they happen to have a certain amount of time in distance, and one transaction went into a single block in Fabric, and the next transaction goes into the second block, the second transaction will be rejected, because the way that Fabric operates is it sends a transaction proposal to all the peers. They respond to with the data that they already have in the ledger. So if they see that the batch is already, or they have available the 15 kilograms, it will get that response back as a truly transaction, right? If I send the same transaction again at the same time before it gets to the order and committed to the ledger, the peer will respond that it still has available the 15 kilograms, and it will respond successfully to me. But if I take both of those transactions and send it to the orderer, the orderer will compare and will see that I'm reading and writing the same key twice. So it will reject the transaction. It will reject both of those transactions for me if they happen at the same time or in the batch timeout, which is by default is 2 seconds in Fabric. You can tweak that when you're creating a network. But by default, it's just 2 seconds of waiting for transactions to commit in a single block. It will reject those 2 transactions if they read and write the same stuff. If they have some time in difference and one transaction managed to go in the same in a single block and the second transaction arrives later than at that time, the orderer will reject the second transaction because of the data that they read. The peers respond with the version of the data that they read is not matching the current version of the ledger. So that's mostly how the ordering works on Fabric.
Thank you.
Is that cleared up?
Okay.
Yeah.
The key there is what Fabric does is read write sets. Creates it coming in, creates a snapshot. When it goes back out, before the commit takes place, it does another comparison of the original read, right? And if there's any change, then it's a rejection.
The separate transactions.
Now, the issue of, are you referring to at the application layer? When you're talking about keys, when you're punching, right? The transaction that you're sending, because you can't effectively send the same without, you can't effectively send the same transaction internally because they're all going to be key. In other words, once it goes into your front-end server from your application and enters into the network, it's going to get stamped. So there's an internal key mechanism that'll never be duplicated. So every transaction coming in will be unique, even though the payload, the data that you're sending, which is what you're really referring to, right? Where you're sending the same thing twice, right? But once it gets into the network itself, those are really separate transactions. And that's where whichever first one gets in to the peers, because you're usually targeting, each participant would be targeting a peer, right? Which would be your peer that your application server has been assigned to. So it receives your application, right, and then sends it to that peer. So that peer is always going to get those transactions. Now, if they both arrive at the same time, they're going to be ordered, queued up, right? And then that's when the read-write set will be created. That will become the initial one. At that point, it'll be sent back out to the other peers. The second one right behind it will again get created, right? And it will go too. But when they come back in, right, after the proposal process is completed, prior to the commit, there'll be the read of that original set. And then at that point, they'll be dropped off. The second one will be dropped off. The first one should still be good.
Yeah, I mean, it should work like that. Have you discovered any, well, are there any security issues you discovered? I mean, it sounds like an example, but.
And that's what I was thinking too, because one of the biggest problems right now in Fabric is the scalability of the peers and the ordering process, right? Because of the latency that happens.
That's what I'm.
Yeah, and things get screwed up, right? Because you get into a bottleneck situation where the transactions part of the time's out because of latency, right? And you have an application that is a serialized process, step A, step B, step C. And it gets into basically, you can not theoretically, you get into basically not a race condition, but a block. Because the first transaction at the application layer can't complete, right? And that's because the peer, and then the application dies out, so the rest of the peers that are in the consensus consortium never complete the transaction and they just sit there. So, I mean, that's from what I've been experiencing. It's
Yeah, I mean,
you get beyond 4 peers and then the geographic network itself.
yeah, that's the other thing. I mean, you got distributed orders and geographic issues and servers and I don't know. Yeah, I mean, this example seems perfect, but in scale and production, maybe. So, Diego, do you see? Can you tell me, okay, like some issues you discovered that are limitations in this model? Do you have any that you can share?
So actually, I was doing some performance optimizations for a client last week. They were having some issues while sending a lot of transactions, a lot of concurrent transactions. I found those a slight problem of performance mostly, but it was mostly related to the coach CP, since the coach CP, the peers sometimes reads and writes to the coach CP when they're committing times. And the coach CP is eating a lot of CPU usage. If that gets throttled, the whole transaction stuff gets throttled and start giving some timeouts. So yeah, the solution for this client was well, it was a combined solution. On Coach TV, you want to use indexes for easily reading write data to the word state of the Coach TV solution. That improved a lot, like 50% of the commit time was improved just by adding indexes to this client. Improving the CPU consumption or availability for the Coach TV also increased a lot. And yeah, there is a lot of planning as well, and how is your transactions going to take place in terms of this concurrency and key collision problem, because this client that I'm telling you, they had a lot of collisions. They needed to write a lot of data on a short amount of time. They needed to run like 1,000 records in less than 30 seconds. And they needed to run all of this concurrently, but their key will colliding. So mostly what I ended up doing was creating a batch function to read all values at once and write into the ledger in the same transactions, so to avoid having 2 transactions and end up with a key collision situation like the one that you were explaining. But yeah, other than that, I think for scalability, we haven't had so much issues since we implemented the raft ordering, and the ordering is now distributed. If one order is down, another order is going to take the leadership, and based on the consensus policies that you define for each of the networks, you can like accept certain amount of tolerance or failure tolerance. If an order is down or 2 are down, you can just rely on some other order available in the pool. And the same thing with the peers. You can just define the policies that each organization can have 2 or 3 peers dedicated to the same channel. And if a single peer is down, it can just go to the second one. And based on policies that you define that I just need one of the peers to sign this transaction, and that will be enough to reach consensus. So yeah, we haven't had any situations like that, like having like a bottleneck situation yet. But yeah, I'm really encouraging to have a situation like that, because I really like to solve problems like that.
But in fact, the core fabric team just updated the reference model sample to reduce the number of peers from 4 to 2 for required signing because of this exact issue. Okay, so where before they had it designated that 4 peers had to sign, they backed that down to only 2 peers required to sign. And that was propagated because of this exact issue, which is also related to what you're referring to with the database, which is because you have to look at the ledger is really is two separate data stores. There's the ledger itself, and then there's what we're referring to as world state. And that's what we actually read from, which is the world state. So the solution, and this is where you get the bottlenecking. So the solution is to scale horizontally the world state in order to be able to consume the read-write issues. Because when you have an application that is, say, writing 10, and then all of a sudden world state is getting hit with a read of 1,000, you have issues. Okay, because now it's exactly what he's talking about, is that the world state gets consumed by the reads of the CPU layer, and they starve, right? And that will ripple down and affect the writes. So there has to be a balance there, and ultimately the solution will be to decouple, like we've done traditionally, like Cassandra, right? The Cassandra model, where you basically partition and you write to this cluster through a load balancer. So the load balancer front end to request to come in and say, oh, you're a writer, you're going to go to the writers, right? And then, oh, you're a reader, you're going to go to the reader cluster. Because the reader cluster has 100 nodes in, or 100 servers in it, but our writers are 10, right? So eventually we're going to get to that point where we partition it, but it makes the network far, far more complex. Because why? Because every node has to do that. Right? You see it, right? I mean, in today's traditional world, your data store is centralized.
Mm-hmm.
So you can scale horizontally and vertically. You can partition, right? You can, but when you're decentralized, right? I mean, look at the nightmare now, right? Because now it's not a complexity of 10, now it becomes a complexity of 100. So you know, there's a lot of networking architectural infrastructure that's going to have to be built out. And that brings me to my question. So you're leveraging Kubernetes right now, right?
Yeah, correct.
Okay. So help me understand the mocks. Okay, so you're mocking, what are you mocking? The Ledger API?
You mean for the unit testing here?
Yeah, when you do your controller and you're creating your mocks, right? Is that actually mocking the Ledger API?
Is mocking the Fabric stop, the Fabric shim API. Yeah. Okay.
Okay. So you basically replicated that. And then, so that we don't incur the asynchronicity, these latency issues. That's why it goes so much faster, right? So then, and the value, I'm just trying to clear in my mind. So the value of that is to proof out your application, the application logic, without having, in other words, it's sort of like at the architectural level. We start with a unit test, and then once our unit test is completed and we're satisfied, we move it into a system test, so that, you know, let's say you have 100 developers, each one's developing modules, each one's unit testing their modules. Those unit tests all succeed. Now they're all elevated and promoted into the system, where now they undergo system testing. We know that the unit testing is correct, so the functionality of the code is correct at the unit layer, but we don't know how it performs at a system layer. So that's sort of what the mocks are, is really, it allows us to unit test the chain code that we're building within our application scope. Then the next step in the process is to replace the mock controllers with a local instance. So a local instance, right? Now that local instance could be large, right? Not necessarily on your laptop, but within one single subnet in your facility, right? So now you have a control second step, which is beyond the mock with a live blockchain, but that blockchain is actually running. Are you at that stage? Are you actually using? Would you say use Kubernetes or just go with a Docker environment at that point?
You can use both actually, yeah.
So your tool, when you generate the network, what kind of granularity and control do you provide for defining that network and those relationships among those partners? For example, I want 4 channels. I want I want 2 participants on this channel, 4 participants on that channel. I want private data on this channel, etc. What kind of granularity do you provide, as well as port control too?
Yeah, the utility that we have to run on Kubernetes, it creates organizations independently, it creates channels independently, and the amount of organizations in those channels are independently. And private data comes enabled by default. The features, the kind of granularity we don't have yet, but they're in the real near roadmap, are specifying something like commit time and things like that, like special configurations of Fabric itself. But all the other like macro aspects like participants, channels, chain codes, all those are controllable by you and by API actually.
Okay, so you basically create a skeleton with defaults, and then with that you can go. The architect, the developer, the sys guy can go in then and modify the ports, the timings, because there's a lot of timing. There's a lot of configuration variables inside a simple Fabric network.
Yeah.
So,
yeah.
right? So you're going with basically the defaults, and then it's up to the developer to go in and tweak that?
Yeah, actually for Hurley itself, the local network that you create on Docker as well, you can do the exact same thing. So we have this Hurley JSON file where you define all the channels that you want, all the organizations that you want, and which channels this organization is included, and all the users that you want on that organization, stuff like that. So you can create really versatile environments for your tests.
Okay, and that will create all the keys, that will create all the self-signed certificates, that will create Genesis blocks, etc. Yeah,
correct.
Okay. Well, that's a big help right there. Definitely. Okay, and then, okay, I see you have users. So users are those in Fabric. It's a little confusing as to.
Yeah, I know your feeling. Yeah, those are Fabric users registered on the certificate authority, so they are identities allowed to send transactions to the network. Those are not, for example, peer users or administrators of the network and stuff like that. They are more like committers or transactions. And
right. Okay. Because I think that term. I think down the road, Fabric, the architectural team really should change that term, because when people say users, people think of Bob and Mary, who's actually going to be sending the transactions, and that's not Bob and Mary. Those are basically entities, machine type entities, logical entities that have the certificate capability that you can send a transaction to them, and then if you're authenticated by them, then they will send the transaction, and that's the user that you refer to there. So how do you define, when you use your tool, how do you define that bootstrap, that owner administrator, and then the MSP administrator?
Yeah, no, those are, because our goal is to abstract complexities from the end user. The end user only wants to, like, hey, I want a contract, I want it to deploy right now. We abstract all those complexities and set up some defaults for the networks that we create. So we just expose what the really end user of a Fabric network wants, which is the users that they want for commit. We do expose the users that are administrator of the peers and networks and stuff like that, but we try as much as possible to don't involve the end user with that much information.
So you create those, but you do that by default, so the user doesn't have to think about it or deal with it. That's right?
Yeah, correct. Yeah, correct.
Okay.
Yeah,
Cool.
and to just go back quickly to the stuff that you were talking about, the process flow, on how you first start developing, creating your unit test. We actually use test-driven development when we're creating new features. So we can just put the test runs on a watch and code against the test, so just to make them pass and things like that. We have some clients, some other clients that they are using, for example, Forma on continuous integration environments. So now that they have developed this end-to-end integration using Hurley and running the test locally on their local machine using Hurley, and they're sure that their components run on a local Fabric network, they can just go to Forma and configure their continuous integration environment to just start making calls. So I want to create a new network, so I call to just network, create a new network. I pass all the organizations that I want. If I want to deploy it to a specific cluster ID that I have registered, I pass the cluster ID that I have. If I want to create a new ledger, for example, I can do so by, let's see, ledger. I think it's missing, it's a document. If I want to deploy a new smart contract, for example, I just pass the network that I want, the ledger that I want, and the smart contract. I just upload a couple of fields, for example, the same fields I was showing you in this section in here, where I just pass the name, the description, the smart contract, and everything, but just do that from this API. So we have teams creating continuous integration scripts, creating networks, running the end-to-end test that they created with Convector on that new environment, and shoot it down after their tests are passed, or leave it open so a manual QA can just verify all the processes working, or even to deploy it to an stage environment and things like that. So yeah, it's really convenient the way that this let you like perform your development, your whole development process from the ground up, just starting from code up to deploying this into a real production environment.
Cool.
All right. Anyone else has any questions? I think as we reached the end of the presentation. Yeah.
No, I think we're, no questions. Nope, no questions.
Awesome.
Great job, Diego.
Okay, right. Well, thank you very much, everyone, for your time. I hope you like the presentation and Convector overall. I want to invite you to join our community. If you go to community.covelenex.com, you can join our community on Discord. There is a lot of people talking about Convector and migrating from Composer and Fabric in there. So it's a daily, it's a really active community. So just pass by and say hi if you want.
And are you looking for committers too?
Sure, for sure. We're looking, we have a lot of features that we want to develop. Time is always a constraint, but more hands is always helpful.
Okay, and you know, now you talked a lot about, just real quick, but you talked a lot about Fabric, but you're also working with Corda, right? I mean, robustly now, right? And I saw Quorum too, and Quorum is derived from Ethereum. So can you just give us a little hint how that's going?
Yeah, so on Corda, we're already supporting it on Forma. Forma, this is a deployment infrastructure. You can create Forma networks right now on Corda networks right now privately. And it's in beta stage. We're about to release it on production grade for join the mainnet of Corda. For for Quorum, we are just in the process to start developing the adapters for that. And the same thing goes to Convector. We're actually talking with the communities of Corda and Quorum so they can give us a hand on supporting both of them inside Convector, like making all the transpilers that we want to do and all the stuff. I have already some experience as an Ethereum blockchain developer, so I'm really familiar with that pretty well. But yeah, more hands are always helpful. The process of doing that will be mostly creating the adapters that we need from Convector to communicate with each of those blockchain technologies, as well as the necessary transpilers that we need to convert the TypeScript code into Java or Ethereum code. Yeah.
So the roadmap is the tools that we saw today will be synonymous with the other blockchains, so they won't be a departure to depending upon which blockchain you go to. What I'm trying to say is that once you learn Convector, then you'll be able to in the future be able to actually use these same models and controllers agnostically with these other blockchains, right?
That's our goal, yeah. Yeah, that's our goal. The same thing as you put an adapter in here for Fabric itself, and then you inject the adapter to the controller. We want to do the exact same thing for the other blockchain technologies.
Right, okay. Okay, well that's admirable, and I mean, obviously, I wish you a lot of luck and great success, because that will go a long way into pushing forward the adoption of blockchains, because I don't know of any tools that are cross-platform at the development level.